This is Shenyang Yuan, and my student number is 14105586. The topic of my research project is feasibility research of two-factor authentication method based on dynamic password. The first, introductions. With rapid development of network, people are paying more attention on the security of information transfer. The password is used as a common identity authentication to protect user information. Common passwords are static password and dynamic password, but both of them has the shortcomings. So we have redesigned a new two-factor authentications for these shortcomings. Next, I will introduce the advantage and disadvantages of static password and dynamic password in detail. The static password, the advantages. Because static password is based on what the user knows and what the user owns, so it is easy to remember. Static password usually only need to enter the username and password, and no other operations are required to otherwise. So it is convenient to operations and less time consuming. The disadvantages. Because static password is unique and unchanged, the attackers can easily obtain the password and steal the user's information and properties. Next, dynamic password. The advantages. Dynamic password changes at every request and cannot be copied or pasted, which avoid the defects of static password. Dynamic password not only take into account the advantages of static password, such as low cost, convenient authentications, and rapid response, but also enhance the security of authentications. The disadvantages. Because backward hash chains as the carrier of the dynamic password. Once the chain length of the hash chains generated by this method is determined, it cannot be changed. So the numbers of dynamic password generated by this method is also fixed. And under the normal situations, there is a certain time interval between the two logins of the users. If the attackers speculate based on the several dynamic password, or use other method to obtain the dynamic password for the next login, the attackers can successfully attack as long as the user pretends to be the users before the user login the next time. Next is the implementations. In this project, it had the four main stages: the register stage, login stage, verify stage, and interceptor stage. The first, we will introduce the interceptor stage. Every controller functions we wrapped it with these interceptors. If the users do not have the permissions, they cannot request these controller functions. So each time the users want to request the controller functions, they must verify the TOTP, and the TOTP can only be generated after successful authorized by a static password. This is the logic of our design. Because in our project, the index controllers is the controller functions we want to protect. So I added the login controllers, reject controllers, and verify controllers in the white box. These three controllers can access by everyone. Another reason is that if reject, login, and verify controllers add an interceptors, the users will not be able to perform two-factor authentications. So we here only added two-factor authentications to the index controllers. That's the code to add the login, reject, verified controller functions in the white box. That's the main functions of the interceptors. The first part is to check if these controller functions need to be intercepted or not. If it's needed, they will get the OTPs from the verify stage and check the OTPs in the database, and also check the UIDs if it's equal in the database. If it's successful, they will return the true values. If it's none, they will redirect to the verify pages, stages, or return to error pages. They will show to the users they have no permissions to access this part. I can show you in my programs. If here we access the index and they will return the error pages, you do not have the permissions to access this controller. Let's back to the PowerPoints. Next stage is the regest stage. The regest stage will save the names, password, and emails in the database and return the true values. I show in my code and I show in my program. Regest. And here we need to regest the users. And these emails we will use in the automatic test. And we click the regest and return the reject successfuls. And now the data will save on the database of the users. And now the data will save here. And next is the login stage. Login stage have the three parts. The first function is generate the one-time password. I'll use the TOTP libraries. So here is going to generate the one-time password and to save the UIDs, code, and current time in the temporary order tables. Once the login function request, they will generate this part. They will generate the one-time password. And next function is the send email functions. They will send the verify code to the regest emails. And this is the main functions for the login stage. The first servers will check the username and password, and once correct, it will run in the create OTP functions and then OTP functions and return the true values. I show you in my program. Here I need to input the username and password. And we'll jump to the verified stage. And next is the verified stage. Oh, I also need to show you the tables here. In the template order, they have the code generated and the timestamp and the UIDs. And in the verify stage, the first they will get the UIDs from the login stage. And here is going to check the OTPs in the database. If it's correct, they will check the available time. If the available time is greater than the available time, they will return the false. If it's less than the available time, they will return the true values. And I show you the programs, and we get the emails. We get the TOTP emails. Sorry, the network is slow. And here is the code 51 7914. And once we click, once we enter this code, then we'll jump to the index page. Before we type the index here is we don't have the permissions, and now we can access. And we're back to the slides. The next, this is the index controllers. In the index controllers, we wrapped it the OTPs. The OTPs is the OTP interceptors, which we introduced in the first. Once they successful, once they return the true values from the OTP interceptors, we can run the next functions. And next, we will introduce the experiment. The experiment here, we compare the durations that the user requires the private APIs, the controllers, through the two-factor authentications in different countries. Here we use the VPNs to simulate the users in the different countries and program these automatic test functions in the Java language. This is the code of our automatically test. This is the first part. First part, we will I will input the test users and test password here, and we'll do the post functions to the login APIs, and we'll save the TOTPs and current time and UIDs in the record tables. The record tables is used to do the data analysis. Oh, the first line here, we use the libraries, the Java library scheduled, and that will automatically run the whole processes every 5 seconds. That's the code to connect to the user emails and pass the emails. Here we use the POP3 to retrieve the Gmails. And here is the test user's email address and password. And here is going to get the read the inbox and open the inbox and read the unread emails. And here is the main functions that automatically retrieve the TOTPs in the email and run the verify stage, and then calculate the response time. Here is to get the message from the email. The content is, because we only send the code to the users, so the content here is the dynamic code, and we replace the space here. And here we'll check if this dynamic password is in the database. If it's not, we'll print that they do not find the code. Otherwise, we will run the post functions to the verified APIs and get the results. And we'll print the results here. And we'll save and this is to calculate the durations, to use the end time to minus the time that we generate the one-time password and minus the 5,000. The 5,000 is the system will run every 5 seconds and divide by the 1,000. And we will save the durations and the result in the record tables as well. And this is the code to export the experiment tables to the locals. That is easy for us to do the data analysis. The last is the data analysis. We compare the average times that users request 100 times in the China, UK, US, and the Japan. As we can see the left tables, the controller functions we upload to the servers in China, and the average request times of the China is the 15 seconds. In US is the 11 seconds. In UK, it's 17 seconds. And in Japan, it's the 20 seconds. It can be seen that the functions of the two factors authentications does not affect or slightly affect the request time due to the location of the service, but the response time is a little bit longer. The average times is around 16,000. But our two-factor authentications increase the securities. And we can see the right tables. Here we compare the frequencies of the user fails in 100 requests in China, US, UK, and Japan. We can see in China it's only 1%, and in US it's 0%, and in UK 3%, and in Japan it's the 2%. The request fail rate is very low, about 2% on average, indicating that the two-factor authentication schema designed in this article is stable. For these testings, we find our two-factor authentications is more securities, but the response time is a little bit longer. For the future works, we can optimize the algorithm to shorten the response time and improve the user experiments. And I will show you the tables I download from the automatic runnings. That's the tables. This is Japanese tables. Thank you.